Yeah, good day, everyone. I welcome you to today's physics lecture series. It is Access Point Academy physics lecture. Topic: Fundamental and Derived quantities. So, in physics, there are quite numerous quantities that we need to know. Some of them, which are scalar quantity, vector quantity. So we also have fundamental and also derived quantities. So in this lecture, we want to learn fundamental and derived quantity. So we start with the fundamentals, which means the fundamental quantities. Now, fundamental quantities are quantities that are not dependent on another quantities. Okay, so they are the basic quantities. They are natural quantities that are not dependent on other quantity. So they are also known as basic quantity. Okay, so in case you don't want to call them the fundamental quantities, so you can call them basic quantities. Now, in the same way, if we have basic or fundamental quantities, then we can also have their units, and the units of the basic quantities are known as the fundamental units. Okay, so we have fundamental units. So fundamental units are the units of fundamental quantities. Okay, so they are not dependent on other units. They are also called basic units. Now, the table below will give us examples of fundamental quantities and the units. So they are just 7 for now in number, which we need to learn and know them. Not only knowing them, we must know them with their units and the unit symbol. So the first fundamental quantity we have length, then mass, time, temperature, electric current, amount of substance, and also luminous intensity. Okay, so these are fundamental quantities, and their units are length. The unit of length is meter, unit of mass is kilogram, unit of time is seconds, unit of temperature is Kelvin, unit for electric current is ampere, amount of substance, which is also known as the number of mole, the unit is mole, while luminous intensity, the unit is candela. Now, the unit symbol, metal is m, kilogram is kg, seconds is s, Kelvin is k, capital K precisely, and ampere is A, moles is mol, while candela is represented as CD. So now these are fundamental quantities, okay, that we have in physics. Now we also have derived quantities. Okay, now what are derived quantities? Derived quantities are quantities that are obtained from other quantities. Okay, they are derived, they are not themselves natural. Okay, they are derived, so they are dependable quantities, that is, they depend on other quantities. Okay, so now derived units are units of derived quantities. Okay, so like we have in the fundamental quantities where they have their own unit, derived unit as well as their own units. So derived units have their own units. So now we also said there are numerous derived quantities. Yes, they are derived. So there are many. There are many. So examples of which are given in the table below. So we see them as many as they are. I've been counting like 10, more than 10, 15 and above, like 21 or so in the table. So these are derived units. They are more. So we have area, volume, velocity, acceleration, force, pressure, density, work done, energy, power, impulse, momentum, moment, electrical resistance, electromotive force, inductance, capacitance, specific heat capacity, and also latent heat. So these are among those that we would mention now. There are many of them. Now they also have their units. We have meter square, which is the unit for area, and this is the unit symbol m raised to the power of 2. Then we have meter cube, m raised to the power of 3, which is the unit for volume. Then we have velocity, meters per seconds, speed, meters per seconds. Velocity and speed are dimensionally equivalent, so they have the same unit. Then acceleration, meters per second square, ms raised to power 2. Force, the unit for force is Newton. Unit for pressure is Newton per meter square. Now, as we have the symbol there, density is kilogram per meter cube, as we have the unit symbol there. Then joules, which is the unit for work done, joules. Energy, joules. So energy and work done have the same unit. We also have power. The unit for power is watts, symbol W. Impulse is Newton seconds with the symbol ns. Momentum is kilogram meters per seconds. That is the unit for momentum. The moment, which is dimensionally equivalent to work done, is Newton meter with unit. Electrical resistance, the unit is ohm, from the name of the scientist George Simon Ohm. Okay, so and that is the symbol. We have the electromotive force, volts, with V. The inductance, the unit is Henry, okay, with capital H. Henry is also a name of a scientist in science. Now capacitance, the unit is farad, so we have it as F. And then specific heat capacity, which is joules per kilogram Kelvin, specific heat capacity. Then the unit for heat capacity is joules per Kelvin, J per K. Then latent heat, joules per kilogram. So we have that, though all these are derived quantities, okay, with their units. Now there is something they want us to note here, that we should note, however, okay, it should, however, be noted that some quantities are neither classified as fundamental nor they are derived, but rather they are known as intermediate quantities. So they are not fundamental. You can't class them as being fundamental, and at the same time you cannot count them as being derived. So they are known as the intermediate quantity. So example is solid angle. So solid angle is an example of is an example of intermediate quantity whose unit is steradian. Okay, so that we have explained fundamental and derived quantities. Thank you.